Well, hello everyone. Thank you for coming out to the Science Nashville meetup. I know we missed a month or so there. We're going to try to be a little bit more studious about meeting once a month. So with that being said, if anyone here has an idea for a talk or knows someone who would be a good speaker, please see me afterwards or email me, right? I'm always happy to give a talk, but I'm sure you guys probably get sick of hearing me talk about the same things. So today we're hosting 4 talks, recent graduates from the Nashville Software School, Data Cohort 2. We're going to do a 15-minute format with 5 minutes for questions afterwards. So if you can, hold questions, unless if you guys feel differently, you feel free to say, interactive presentations. But with that being said, first speaker is Glenna Dunn. She's a graduate research assistant at the very end of her PhD here at Vanderbilt. And with that being said, take it away.
So for my capstone, I studied Twitter propaganda accounts. So in case anyone's not familiar, these are fake accounts that are run by propaganda organizations. The most famous example was the Internet Research Agency, which was run out of Russia and was very active in the political discourse leading up to the 2016 presidential election in the United States. They've also been active in the discussion of Brexit, Ukraine and Crimea, and other ongoing political discussions. So this is just an example of some of the tweets from a fake account that I was able to find that are not offensive. And this is, so this Tennessee GOP, this is an account that was masquerading as the Tennessee GOP party on Twitter and is not real. Okay, so this data I retrieved from 538. They have it posted on GitHub. It's a data set of about 3 million tweets from about 3,000 fake accounts. And they've done a little bit of cleaning and organizing of the data. It's pre-labeled, so they were able to break it into a few different categories. The 3 most prominent categories were right-leaning trolls, left-leaning trolls, and fake news feeds. And I will occasionally rely on those labels in my analysis. So one of the first things I did, and honestly some of my favorite analysis in this project, was just looking at the timestamps of the tweets. So here we're looking at the flux of tweets over time for the year of 2016. And it's number of tweets per day. And the gray line represents the total number of tweets. And then the red and blue lines represent the right-leaning and left-leaning trolls, respectively. So you can see that it's very active, and there are these sharp spikes in activity. And some of them are overall spikes. You can see a big leap up in gray. Sometimes it's just red, just blue. So what I did was I went through and looked at those dates and tried to glean out information of what was going on in our country during that time, and around the world as well. And I found 3 types of events that coincided with peaks in this activity. The first one was terrorist attacks. So the Brussels terrorist attack, also the anniversary of 9/11. There were, so one of the other things that was going on during this time was the WikiLeaks and other data dumps. And a few of the spikes in activity are also coincide with those. So there's the Guccifer 2.0 email leaks and also the Podesta email leaks. Those are lined up with spikes in activity. And then the last category was political events. So party nominations and election days all coincided with peaks in activity with these accounts. So I wanted to look at just single accounts and the activity of a single account and see if it looked like it was a real person or not. So this is, again, the Tennessee GOP account, and we're looking at, on the y-axis, we're looking at about 2 months of time in 2016, the months of October and November. And on the x-axis, it's a little bit cut off, so I'm going to so this is hour of day. And so I'm basically taking an adjustable circle to represent the number of tweets per hour that the account is putting out. And wanted to see if we saw any features. So there's 2 features that I noticed in these accounts. One is, and this is a good example of it, there's this observed rest break that shows up for weeks at a time. The account is not active or was for the same period of time, day after day after day. That's one feature. Another feature is just the constant flux of tweets, and sometimes the total number of tweets per hour would exceed the likely flux of tweets coming from an individual. So here we can see, so Jen Abrams, I picked this account. This was kind of famous in the news when these accounts were being realized as propaganda. This fake person had accounts across several platforms. I believe she also had a live journal. So there was really a lot of effort put in to make sure that these looked authentic. So you can see that the activity here is a little bit more sporadic, but there are times when the flux of tweets exceeds 40 or 60 or more tweets per hour. That's quite a lot of tweets for a person to be putting out. And here's one of the most prolific tweeters that I found in the account. So again, we're looking at 2 months of activity and the hours over the day. You can see that there was like maybe a 32-hour span where the person was putting out more than 60 tweets per hour. So this is saturated at 60, so it could be quite more than that. You can see that there's activity with really no rest break for about a month. And then the other feature that's interesting is that there's quite a steep drop-off in number of tweets right around the week of the presidential election, which is this week right here, marked as 2016-11/9. So just by looking at the timestamps, we can see some really interesting features that show us that this might not have been real people. So I wanted to dig into what exactly they were tweeting about. So I just looked at some of the top n-grams. Top 10 words, it might not surprise you. These are talking about the political nominees and important issues going on in the US during this time. If we look at the bigrams, it starts to develop a little bit more. So you can see names showing up: Donald Trump, Hillary Clinton, entities like Fox News, White House, and then you can see here Black Lives Matter is showing up, and it's going to show up in the trigrams. So now we're seeing Real Donald Trump. This is the user handle for Donald Trump. Some of these are hashtags. Black Lives Matter was very prominent in the discussion of particularly the left-leaning accounts. One of my favorite features here is that CNN fake news CNN is a popular trigram, and also fake news CNN fake news is a popular trigram. So you can see that CNN was really taking a beating. So I looked at using pyLDAvis to try to do some topic modeling, and I'm actually going to X out and go into the notebook so that we can be interactive. So I experimented with a number of topics, trying to find some widely spaced topics, and I settled on 5 topics, and we can then hover and look at the words that showed up in those topics. So this topic looks like it's talking about a little bit about local news. It's mentioning Brooklyn. It also looks like it's talking about terrorism, and then we can go to another, and then this one seems to be very much talking about politics. Trump, politics, Aleppo, Hillary, President Obama. These are obviously talking about people who are running for president or were currently president or very active in the political scene at the time. Our third topic shows a little bit of overlap with talking about Syria, local news, army, election. So you can see that there's while they are widely spaced on the diagram, there's a bit of overlap. Fourth topic, this is talking more about police. One of the big discussions was police interacting with the community, police brutality, guns and violence. Those were big topics among these accounts. And here we have another local news account. So this is talking about cities in the US, Miami, Cleveland, talking about sports, shootings, and a little bit of a discussion of terrorism as well. So I wanted to dig into a little bit more of what they were talking about. So I looked just at hashtags and retweets and mentions. So these hashtags are commonly used to summarize the topic of a tweet. Retweets and mentions, those are showing us who the tweeters are interacting with. So this is broken out by the 3 different labels I'm using: right trolls, left trolls, and news feeds. And these are the top accounts that the trolls are interacting with. So you can see with the right trolls, it's very much talking about politics and interacting with the people running for president and news organizations. So it seems like very siloed to that topic. Whereas if you look at the left-leaning trolls, there's a little bit of overlap there. Donald Trump shows up, POTUS, and Hillary Clinton show up in these top retweets and mentions, but we also see some evidence of talking about issues like Black Lives Matter and gun violence. So there are a few very prominent social justice activists who show up. So here we have DeRay, this is DeRay McKesson, Sean King. So these are people who are very active in the Twitter sphere talking about social justice. And then we also see a little bit of so Bernie Sanders makes it in, and a little bit of reference to music, and that'll show up again in the hashtags. And then the news feeds, so the news feeds are much less prominent as compared to the right and left-leaning trolls, and you can see that it's encoded just in the frequency of the top tweets. But they're still interacting with real Donald Trump and a few real news accounts, and then some news accounts that I have not verified. So they're really staying in the news space, though it's not yet clear to me whether or not they are interacting with fake news accounts or real news accounts, or some mixture of both. So we're going to do the same analysis with the hashtags, and you can see again there's this diversion of topics with the 3 groups. So the right-leaning trolls, they're talking about Second Amendment rights and conservatism in general, fake news, Trump, and some of talking about debates. And the left trolls are really talking about social justice issues, Black Lives Matter, and Black History Month. And then there's a little bit of mixture in there with talking about some pop culture and music. And then with the news feeds, top hashtag is news, talking about sports, local news, and kind of like other hashtags that you would see that kind of makes sense to show up with news feeds, top news, local, that kind of thing. Okay, and then I wanted to look at the correlation matrix of the hashtags. Basically, I wanted to see, I hope people could see this, try it going up one. Okay, so I wanted to see if there were any off-diagonal correlations between the tweets, so that hashtags in the tweets. So like one strong off-diagonal pair is TCOT and CCOT. So if you don't know, TCOT is True Conservatives of Twitter, CCOT is Christian Conservatives of Twitter. So that was one strong pair. So one that was pretty disappointing is there's a correlation between Islam kills and ISIS. So it just goes to show you like the meanness, I guess I would say, of some of these topics. Talking about debates, so some correlations aren't that interesting. Talking about debates, and so then the last topic I'm going to talk about is pairing named entity recognition with sentiment analysis. So basically I wanted to extract who and what were the most common named entities showing up in those tweets and what were the sentiments of those tweets. So I used spaCy to extract the named entities, and then I used VADER for sentiment analysis, and this turned out to be a really good tool for working with Twitter data because it incorporates emojis and capitalization and punctuation into the analysis of the sentiment, and since that is how people talk on Twitter, it seemed like a great tool for analyzing Twitter data. So this is just kind of a visualization of the named entity recognition of some tweets. So it's pulling out geopolitical entities, organizations, people, and tagging them. So these are some of the top entities that were recognized as people. You can see that many of them are people. A few exceptions are, so Zika is not a person, it's a virus. And then Oscar, so Oscar is the Oscars. So in 2016 and following years, there were big discussions about the lack of diversity in Oscar awards. And so there's a huge excess of negativity talking about Oscars, the Oscars. And then the other things just kind of break down the way you might expect. So there's Comey has an excess of negativity. Bill Clinton, Bernie Sanders does a little bit better.
Now, are these in the troll tweets?
Yeah, they're all troll tweets. Yep.
Right.
Yeah. Mm-hmm. John McCain comes out favorably. I wasn't expecting the name Jesus to show up so much, or to be one of the top 20 named entities, but it is, and it has a lot of positivity. And Ted Cruz also ends up in the green. So I think it's interesting to just look at how this breaks down. I then looked at organizations, so top 20 organizations. So some of these are Islam is a religion. I don't know if all religions get picked up as organizations or not. Some of these are branches of the government, news organizations. So you can see that, Islam, ISIS come out very negative. The UN comes out very negative. The only couple that come out positive are, here we have MAGA and we have POTUS. And then finally, we look at geopolitical entities. So these are mostly countries and cities. So most broadly very negative, and you can see a lot of these are countries that we maybe have some conflict with or had some conflict in 2016, cities that had notable events in them, maybe shootings or maybe terrorist attacks. And you can see the only entity that comes out with a large positive fraction is America. Yep, and this is just more of the same. So I think at this point, if anybody has questions about what I did, I can take them and try to answer them.
Do you know how FAT38 selected these tweets?
Yeah. So I believe it was a mix of techniques. Some of them were identified by Twitter themselves. Some of them were identified by the U.S. government in their census of this activity. So it was a mix.
Any like comparison with these are all like fake trolls. Right? Did you in comparison with it, like a real tweeter? Like you gave the example earlier of the Tennessee GOP. I'm assuming you had a real Twitter account.
Probably, yeah. So that is that will hopefully be an upcoming feature. This is a really rich data set, and there's a lot more to do with it. I would have to retrieve data that makes sense for a comparison. And the Twitter free Twitter API has some restrictions on how far you can go back historically to access tweets. So if I would have to either find a publicly available data set that made sense for a comparison or think about a way to engineer one myself. But that's something I would like to do.
And I apologize, I don't know if you already mentioned it or not, but did you ever get a chance to look at where these accounts were coming from?
Oh, okay. So most of them are have been identified as coming from Russia, from the Internet Research Agency. The tweets do have locations associated with them sometimes, but it's very easy to spoof your location and pretend you're somewhere else using a VPN. So a lot of times the tweets said that they were from the U.S., cities in the U.S., but that location's probably not reliable. Yeah.
Do the downtimes in the tweets correspond with their time in Russia?
Yeah. Right. That's possible. It definitely looks like shift work, right? Like it looks like somebody got in. I did. So I wanted to look at that, but I wasn't sure if if there was a normalization in the timestamps because the location may have not been reliable, the time may not have been reliable as well. I'm not sure. I did see that there were multiple accounts that showed this this periodic pattern of shift work, and it wasn't always the same. But they may have had people working around the clock, who knows? Or somebody got in the morning and submitted a script to run. Yeah.
So I have a question. So it seems like you actually work with very messy data. So when you're working, like doing pre-processing and data wrangling, what was the most difficult challenge you had, and how did you handle it?
Yeah. So Twitter data is very messy, and that it was really an iterative process. So I would go through and clean it, and I thought I was done, and then I would get to a point where I realized I needed to circle back and include more. So one of the things I had to think about was how to deal with the hashtags and the @, the account mentions. At first I removed them, but I realized that they are a part of the way people talk on Twitter, and they contain important information. So I decided to bring them back in, remove the punctuation, the ats, and the hashtags. And then a lot of words are camel case, and account names are camel case. So if they were camel case, I split them. And so that was how I was able to get a trigram like Black Lives Matter or Real Donald Trump, because they were camel case split from hashtags and mentions. Yeah.
I noticed that was like that ended up splitting McCain's name into 2 words.
Yes. Yeah. So it does make some mistakes. Yeah. But I think it was just a matter of getting the most of it right for the application. Yeah.
Did you find these different entities retweeted or liked their compatriots?
Yeah. So that is something that I would like to look into in the future.
Network analysis.
Yes. Looking at how the bot accounts interacted with each other, and how they interacted with non-bots. That would be really interesting.
So when you look at the data, so did you notice like any pattern in the location, like in the interview, like around the same location, or does it change periodically?
I didn't look at location for this, other than to just eyeball it and see that for a lot of them the location was either not available or redacted, and then since you can pretend you are somewhere else, I just decided to not use it because I thought it wouldn't be very reliable. Yeah, there was some variety though.
I think we have time for one more.
Oh, I was just gonna ask this question. I don't know if you have a good way to look at this, but have you thought about looking to see the interaction between trolls and like regular citizens, and to see if, for instance, not feeding the troll as an approach works?
Yeah. So that is something that interests me. I would be able to see if a non-troll was retweeted or mentioned by a troll, but I wouldn't be able to see with the data that I have here if the opposite case, if a real person interacted with the troll voluntarily, right? Because that data is not available. So it's not, but it would be very interesting, yeah.
All right. Thank you, Glenn. Our next speaker is Harry Tanjore. He is a research faculty at Vanderbilt, the allergy pulmonary in medicine group. And he's currently looking for a position in data science, guys. So if you're looking for someone to fill a role, and I'll try to be a little bit better about timing. So I will stand up and give you a 5-minute warning when it gets a little close, okay?
Okay. Thank you, Jason, for the introduction. I'm Hari Tanjore. For my Capstone project, I wanted to look at text analysis of the reviews written by patients or the people who take the prescription medications or over-the-counter medications from the drugs.com website. So my key question was like, can we identify the key terms or key phrases in the reviews from the patients, whether we can use these to predict the sentiments of reviews to the average ratings. A little bit background, the prescription drugs or over-the-counter medications can have adverse reactions. So if you look at the clinical trials, they are done in a subset of patients in an environment where they may have adverse reactions or they may not have adverse reactions. However, once the FDA releases the drugs into the market, post surveys or either the reviews from the patients or opinions expressed by the patients can help other patients as well as it can help the doctors to identify which drugs are having adverse reactions. So it is also used in pharmacovigilance which detects and tracks these negative side effects of the drugs, and then FDA can do something about it. Patients can directly report these to their physicians, or they can directly report to the FDA, and then FDA can monitor and do something about the side effects or pull out these drugs or release the better drugs into the market. So this is the data source. So I pulled the data source from the University of California Center for Machine Learning repository. This data was published in 2018 by Surya Kalamadi group in proceedings of 2018 International Conference on Digital Health. This data frame looks like this, and the shape is like around 215,000 data points, and then the number of individual drugs are like around 3,671. And the number of conditions, the diseases that these reviews have been written are around 836. The average number of reviews per drug is around 58. So the whole data set looks better. So coming to the exploratory data analysis, first I looked at the different conditions. So which is the most condition that people are writing about? Looks like birth control and depression are the two conditions on the top of the list. And this is the value counts of these conditions in the whole data set. You can see the other conditions like diabetes, high blood pressure, weight loss, obesity, they're all there. So now started looking at the distribution of the drug ratings. You can see that the drug ratings, they are ratings from 1 to 10. The positive ratings are much higher than the negative ratings, and this data set was from drugs.com. These authors, they used Beautiful Soup to web crawl the data from, I think in the past 10 years, from up to 2017. So if you look at the character length in the reviews, interestingly, more or less, there are average character length is 458 characters, whereas some reviews like low ratings, like rating 2, you can see that there is 10,787 characters. So this person is basically was taking an antidepressant, and he's written all the story when he goes to the party, how he's depressive, the medicine is not helping, like that. Interestingly, if you look at the top ratings, the positive ratings, there are also some top number of characters are higher. I wonder why people with the positive ratings write more. Maybe they want to be more helpful to other patients. So now I looked at the classes. How do you classify the ratings? So I just took the ratings, how they published in the paper. So the positive ratings, anything above 7, between 7 and 10, I've given it as positive rating. Less than 4 is negative rating, and neutral is between 4 and 7. And as you can see that the classes are highly imbalanced. I tried balancing the data with SMOT, using synthetic balancing. But for these studies, I wanted to get the phrases from these reviews, so I just left the classes like that. So pre-processing, so the data was already cleaned, but I removed some punctuations, removed some special characters, converted text to the lower, and I've now removed the stop words because of the medical data set. And then I also used bag of words using TF-DF vectorizer. And then the models I have tested is a Naïve Bayes model, multinomial Naïve Bayes model, logistic regression, linear SVC, and also word embeddings with convolutional neural networks, as well as character embedding with convolutional neural networks. I'm going to show only the Naïve Bayes and word embedding with convolutional neural networks. So this is the base model. As you can see that in the base model, the F1 score is around 80%. The model did okay with the negative ratings. You can see that on the top, the negative ratings. So 80% of the time it was finding the errors, positive errors, and then but the actual true positives are only 63%. Where it suffers is in the neutral rating, which is only 29% in the recall middle column. Whereas it does much better in the positive ratings as expected. There are more positive ratings in the classes. And you can see the classification match in the confusion matrix at the bottom. You can see that it is predicting positive as positive, but some majority of them are negative. But it is also giving some negative as positive ratings, classifying, and where it suffers is in the neutral ratings. And this is the area under the curve. You can say this is the positive class, and this is the negative class, and this is the neutral class, and neutral class has more false positives. It's okay, it's doing its job, yeah. So then wanted to see as a word cloud, what are the feature importances this model is picking. So as you can see, this is the positive wordings. These are the top 50 wordings. You can see that has no side effects. The only side effect has changed my life, no side effects. Doctor put me on my life back. So these are the positive words that the model is picking. And let's look at the negative words. It says like I do not, I used n grams, like 4 grams. I've tried different ones, but I wanted to get the phrases, so I used 4 grams. So do not recommend this, would not recommend this. The side effects are do not take this. So these are the negative words. Stop taking it. These are the negative words. So then what I did was like I was curious to see, okay, let me look at the specific conditions. So I went and, yes?
Sorry, before I forget. When you did the bag boards in IDF, did you also use like 4 grams or 5 grams for that as well?
Yes, yes.
Okay.
Yeah. So I looked at the weight loss. So one would expect that if you're taking a weight loss drug, the positive words would be that I lost weight. Negative words would be did not work on, did not lose weight. So this is the base model with the weight loss. As you can see that it still suffers at the neutral classification in the middle column. The sensitivity is only 27%. And you can see from this data set, the weight loss data set is only 4,000 data points. So it's a smaller set, but it's still doing job. It's better work. You can see that area under the curve, it still suffers the neutral class. It's okay, it's doing, but the area under curve is much better. So let's look at positive classifier in the weight loss. So as I expected, it shows that I've lost pounds. I have lost pounds, no side effects. The dry mouth, some of the negative words like, is also there. Lost pounds, weight, inert. And then you can look at, then if we look at the negative classifiers, so you can say that the side effects were lost any weight. So it's taken as a negative word. And then it did not work as a negative. And then stop taking it, so lose any weight. So some of the words it's picking up as the negative words from the weight loss drug. So then I went ahead and did word embeddings with convolutional neural networks, and this is the base model I've already shown you. This is the CNN word embedding model. So basically I used the top 10,000 words and used 1D convolutional model with the global max pooling, and then used 20 epochs to run this neural network model. As you can see that the F1 score, based on the F1 score, the base model was 80%, and then the CNN model was 90%. I tried to balance here with the class weights. Without class weights, it's just the same better accuracy. Especially you can see the neutral category, it's increased there it was only 29%, the base model, whereas in word embeddings it's gone to 67%. It's doing much better. It's also done much better in the negative category, even though the classes are imbalanced here. And you can see from the confusion matrix, neutral classes, there are more, still there are like false positives, but there's, if you see diagonally, there are more neutral classes, more negative class, more positive classes, more number of predictions. So this is basically comparing the area under the curve, ROC curves, receiver operating characteristics between the base model, and this is the word embeddings with CNN. As you can see that it's doing much better in identifying the positive, true positives. But still the neutral class suffers. And then, so how do we interpret the model? So I did this small library using the Lime. Basically, the model, I'm showing the So you can see that for one of the reviews, which is a positive review, you can see that the model is using this is the base for the demonstration purposes. I'm showing the multinomial Naïve Bayes model. For the positive words, it shows that love, healed, hesitant, and then but negative words, there are some negative words in these ratings. Implant, itched, so some of them. And let me show you. So this is a negative rating. So you can see that the negative words are violently, throwing, horrible, hospital, and then there's some neutral words like thorough, but again it picks up horribly as a neutral word. But overall, the overall this rating is the negative rating. And then if we see some specifically positive rating, so you can see that a positive says like stays, perfect, highly, wow, some of the positive words that is which is chosen.
The predicted rating is based off the star?
Based off
the star rating of the drug?
Yes.
And then the true label is
based on what? Yeah.
The actual words.
Actual ratings, yeah. And then let's see one. I just wanted to show you some neutral rating. So you can see that the neutral is wins, wandering, pangs, actually. So it's picking. So there's some of the positive words are again like it's picking more of the positive words. So going forward, I would like to try with remove the stop words as well as do hyperparameter optimization to run these CNN models to see if it does much better than what I'm getting. That's it. Thank you.
So how did you train the model to recognize what's positive and what's negative in terms of the labeling?
So classifiers, I used ratings as a different classifiers. I divided into 3 classifiers.
Right, but that's for the prediction. But for the true, what was it? Your confusion matrix on the y-axis for the true. So what's that?
You mean to say?
Based off the actual text analysis?
Yes, actual text analysis.
Is it already labeled?
What?
Is it already labeled?
Right. So what's labeled as positive and what's labeled as negative? Did you train?
No, I did not. I did not use any annotated ones as a positive or negative. I just gave this text to the model, and then it predicted that way.
Okay.
Yeah, I understand. I mean, I did not use any. They have used in the publication. They have used 400 annotated that they given as positive and negative. These votes are positive. I did not use it here.
Yeah.
So in order to improve the performance, like accuracy, maybe you should look at the like false positive. So see if you see any pattern, if you see it, maybe you should use some penalty, for those. So that way we can improve your performance.
Sure. So some of them it is picking the drugs. There are ciprofloxacin. It is showing as a positive. Some people, probably some reviews I must have written as, so I may have to remove all those things. Yeah.
How big a window did you use for the word embedding?
5.
How many words?
5 words.
5.
5.
And did you break it by sentences or just went through the whole thing?
Just one dimensional one.
Could you look at some kind of score of similarity between ratings and see if there are any suspicious positive ratings in the data set?
I did not, but that was one of the,
There were lots of tens, and actually I've got no idea whether that's plausible or not. I guess I always felt like kind of more inclined to complain on websites, so to speak.
I know. I mean, I have not looked into that. It's hard to find from the writings, especially from the positive ratings. Like, you would say like, oh, it worked, but somebody has written so many characters about that medicine. Either he's genuinely writing it, or it could be.
I think more to there is very close duplicates.
Yeah.
If you look for very close duplicates, where
No, I did.
words
I did not look at it.
It's kind of, I know that you use the labels provided, sort of chunking up neutral was between 4 and 7. Did you do any experiments with just eliminating that neutral category entirely?
I did not.
Okay.
That's a good idea. Yeah.
I'd be interested to see if it, sort of if you just had a binary classifier and a gray zone sort of design or designated as a neutral score.
Okay.
It's not clearly positive or negative.
Yeah, I have not done that.
Or
Yeah.
eliminating the ones and tens, because those have the highest likelihood of being fraudulent.
But
You could eliminate the ones and the tens and only look at 2 through 9.
I didn't understand your question. Can you come back?
Ignore the 1-star rating
Uh-huh.
and then ignore the tens.
Okay. Yeah. I have not done that. Yeah. I've looked at individually just like a 1-star ratings. It's I looked at just 1-star and 10-star just to see what they mean. I've not looked in detail what you were asking.
There's another technique called stemming.
Yes. I've tried lemmatization, but not stemming.
You don't think it helped?
It did help, but I was not getting the phrases that I was looking for, like apostrophe phrases.
And the other thing I guess to look for would be that there's a corpus of pre-trained word vectors that you could infer would be applicable here.
Yeah, but in the medical dictionary, I'm not sure.
Yeah, that's the truth.
Yeah.
I mean, Google's got these gigantic ones. I don't know whether specific domains or they have specific
Yeah,
words.
yeah.
That's the question.
You demonstrated when you were showing the word clouds that the word cloud is really dependent on the category of drug being reviewed, right?
The first word cloud is the whole data set. Whole data sets
And the second
is the weight.
really had very little resemblance to the first word cloud. And you also showed in the beginning that the data set is like heavily birth control, right?
Yes.
So I'm wondering if a lot of the data analysis is really like a birth control data analysis, and if it applies equally to that category of drugs as to like the least represented drug category in the data set. Do you have any thoughts about that?
That's one. Possibly, yes. There may be birth control is the most reviewed, condition here. There may be overlaps, but I would like to do independent individual analysis on the birth control and other, compare how that's related. But I just did only 2 things here, weight loss as well as the depression, because those 2 makes more sense to look at. That's what I did.
All right, well, if there are no other questions, I think we should move on to the next speaker. It'll be interesting. Okay, so our next speaker is Rachael Abram. She's the Dean of Community Life at Nashville Prep School. Unfortunately, I think that she is leaving us soon to be moving to Knoxville. So if anyone is aware of any remote positions or something in Knoxville, I think that you're looking very actively. So.
Wonderful, thanks Jason. Hi, my name is Rachael Abram, and I will present to you now my capstone, which was an analysis of Metro Nashville Public Schools pathways, and ideally a parent tool for parents and families to use. My motivation for this project, I work right now, as he said, as the Dean of Community Life at Nashville Prep, where I oversee a variety of projects, but my main project for the past 2 years has been ensuring that our school is fully enrolled. Nashville Prep is a charter school, so families have to opt into our school. So I've spent the past 2 years talking to hundreds of parents and kids, trying to figure out what it is that entices them to enroll at a school, what do parents really care about when they're looking for a new school for their kid. And what I heard from families over and over again was that academics was the most important. They wanted to make sure that their kids were on track to be ready for high school, be able to get the highest ACT score, be able to go to the college of their choice, on track to graduate from high school. All of these academic components were the most important things for families. So putting myself in their shoes, what a parent sees when they hear about MNPS are things like this. Every year there are new schools opening and there are new schools closing within Nashville. There are school board battles and school board elections that get vicious on Twitter, sick outs, all kinds of protests here and there. And while this is all very important news and very interesting, parents and all the parents I've talked to, no one has asked me who our school board representative is. No parent has asked me how much we pay our teachers. What our parents really care about is academics. And when you look to the news and do see some things about academics, what you see is that the state test failed again. The state test kind of sort of worked, or that the state test maybe sort of worked for real this year. There's no celebration of kids who got perfect scores on the SAT. There's no celebration of the kids going on track to go to Ivy League schools. There's no celebration of academics of schools that are performing well, which is what I have found is important to parents and to families. This is really important because in MNPS, there are tons of options for families to choose from every step of the way, from pre-K through high school. You could pick a different school to go to every year for K through 12 and be totally fine through MNPS. Essentially, you have 2 options when enrolling your kid at a school. They can go to their zone school based off of their address. X elementary school feeds to Y middle school, feeds to Z high school. Or you've got your non-zoned optional schools. These are magnet schools, charter schools, Montessori schools, anything that is outside of your zoned school. These are what clusters look like within MNPS. So if you have X address, you may go to Cockrell for elementary school, feeding to McKissick for middle school, and then Pearlcombe for high school. And then you see all of these charter schools and non-zoned schools are different schools that you could go to instead of that zoned pathway. So you can see just within these 2 clusters, these are your options. And these options aren't limited to clusters. So like, for example, you can go to Hume-Vaughn High School, even if you don't live in Pearlcombe. Its address is just close to the Pearlcombe cluster, so they put it there. When parents go to look for information about schools, they have a couple of different tools offered to them by Tennessee, by Metro Nashville Public Schools, one of which is the Tennessee School Directory. However, this website, this is what it gives you when you look for a school: address, principal, phone number, what grades it offers, nothing about academics. MNPS has a tool called School Match that's helpful. It allows you to filter by grade, filter by certain programs, such as Avid or Magnet, and then filter for things like before or after care programs. But when you get these results, there's no academic information on this page. Nothing about how well this school performs, how likely it is to get your kid reading on grade level by the end of 4th grade. And when you go to that school profile and click on that, again here it's academic information, it's just the programs it provides. Not a lot of information here, well not really any information here, on the academic performance of kids at that school. Which means families turn to websites like Niche, which is a great website, it has lots of merits. I was talking to somebody who described it as the Yelp of schools, so take with that what you will. But even when you search for the best public elementary schools in the Nashville area, you get a school in Sumner County and a school in Williamson County, so possibly not the best tool. So for my capstone, I sought to build a parent tool that would allow families to have better access to academic data for the schools that were presented to them as options to enroll their kids. So we did a lot of data downloads from the Tennessee Department of Education, scraped a couple of PDFs to get pipeline information for MNPS. Did a lot of data cleaning, lots of merging of data frames, and found this really one interesting thing I wanted to share, that when the state of Tennessee reports out percent mastery or like a percentage of kids who score well on a test, they suppress it when it's less than 5% and greater than 95%. And there are over 50 cases in MNPS schools where this data is suppressed because of this reason. And I, based off of their math scores, other data in the data frames, assumed that this was all of these cases in MNPS were because it was less than 5%, not because it was greater than 95%. In most cases where a school has a math mastery of 7% for the school, they don't remarkably have 97% mastery for reading. I did all of my exploratory data analysis in R, made a lot of beautiful graphs that I loved, but then from there hit like a big challenge in my process where I needed to figure out what was the most valuable information that I had come across and what was useful to parents to see, what could they actually take action based off of, and what parents needed in front of them to help make an informed decision for their kids to go to school. From there, I built a Shiny app that I will now show you guys. Perfect. So this first tab allows you to view mastery over time in pipelines and pathways within MNPS. This shows the median percentage of kids achieving level 3 or level 4 mastery on the TN Ready ELA or math assessment in 2017-18. These scores are grouped by grade level or by school level, elementary, middle, or high, and then again by cluster. So you can see again here, so for example, Glencliff has 20% mastery in ELA, which is reading at the elementary school level. Their middle school has about 12%, and then high schools is lower. Again, I want to note that this is, my bar graph here only goes up to 50. Ideally, you've got 100% of kids on grade level in reading or in math, and even the highest schools here are at 50% for their median. An interesting trend I noted here was that you see a decrease from elementary to middle to high school. So schools that have 50% mastery drop down to 30% when they get to the high school. You can see it really particularly in the Hillsborough cluster and the Hillward cluster, where you have schools like Julia Green that have 80% mastery at the elementary school level, but by the time they feed to high school, that same group of kids, that same cohort of kids has 20-30% mastery. You can view the change in mastery throughout a pathway here. So you can see just how far the decline is, starting at 0 and going down. And in math, you've got this really funky anomaly here where in the pearl cone cluster, it goes up, which is the only case that this happens in all of MNPS. So you might think, I have a kid who's really behind in math, I want them to grow, I'm gonna send them to school in pearl cone because they will help my kid grow from being behind to being a little bit further ahead. But when you go to overall mastery, pearl cone has some of the lowest scores in the network, or in the city. Still not a great option. The average ACT score at Pearl Cone High School is a 16. The test is scored out of 36, and College Ready is about a 21 or a 22. So Still not a great option for your kid. I saw this as being really a tool for parents that were wanting to keep their kid in a zone school, wanting to pick a cluster, stay in the cluster, and be done with it. My next tool in my app here allows you to compare any two schools in MNPS. It puts academic data at the forefront, reading data followed by math data. Then you get some key demographic information, male, female, race, and gender. And then a few special populations, so percentage of kids with disabilities, percentage of students that are economically disadvantaged, and percentage of English language learners. You can compare any school against all of MNPS or any school against another. Does anyone have any requests for schools they would like to see? Hume-Fogg. So that was going to be my example anyways. So one thing that was really interesting to me, working at a middle school, very focused on where it's going to set up our kids to be successful in high school. A school like Hume-Fogg or MLK, great magnet school. But the zoned option for our students is Pearl Cone High School. And so just to compare those two, you can see the ELA percent mastery compared to math. Significantly higher at Hume-Fogg. Hume-Fogg is an optional school you have to apply to. There are test scores you have to have on your TN Ready assessment to be able to attend there. And even then, it's a lottery. Whereas Pearl Cone is a zoned option. I think this gets really interesting in this comparison between Hume-Fogg and Pearl when you get down to the racial demographics and the special populations. So you can see that Hume-Fogg, much more white than Pearl. Pearl has a much higher percentage of African American students, a lot more students with disabilities, a lot more students who are economically disadvantaged, and more kids who receive English language learner services. The great option to compare, opportunity to compare any two schools within MNPS or compare a school against MNPS as a whole. My final tool here is the option to find a school. So my thought process behind this is that, let's say, hypothetically speaking, you have a rising fifth grader. So you'd select fifth grade. You really care about science. You want to make sure your kid is on track in science. So you would choose a tested subject of science. And let's say that your student is Black. This then allows you to filter and see what schools have the highest percentage masteries for kids that meet that subgroup of categories. For Black fifth graders testing in science, you can see that VADER, East End, MEGS might be great options. You can see that those are all non-zone schools, so those are all optional schools. Well, there's that. That you have to apply into. Well. You can also, this is a great tool to identify gaps as well. So in the 8th grade year, it's really important that kids take either Algebra 1 or Integrated Math 1. I took Algebra 1 when I was in 8th grade. Now it's shifted to Integrated Math 1, as being like that 9th grade math course you take. That a lot of schools push for 8th graders to take so that they're on track to get to calculus by their senior year and ahead of the game in math. So it's important for a lot of families that their kid has the opportunity to take Integrated Math 1 and that Integrated Math 1 end of course test at the end of 8th grade. So you might want to search for your 8th grader for their Integrated Math 1 test. And you can see that if you have a student with a disability, there are no schools in the city of Nashville that offer the Integrated Math 1 to a significant population of kids with disabilities, and that's greater than like 10 kids. So if you have a kid with a disability in Nashville, it would be very challenging to find a school that would allow them to take the Integrated Math 1 test in 8th grade. I would love to, in the future, this only allows me to break it down by one subgroup. I would love to be able to have multiple subgroups be available. So if your student is Asian and has a disability, to be able to combine those together. But that is my project. Have any questions? Yeah?
What about if you normalize school performance by percentage of economically disadvantaged kids?
I haven't done that, primarily because my assumption that I could have proved very easily would just be that schools that have more economically disadvantaged students have lower test scores.
So but then can you argue that the percentage isn't necessarily due to causation? So if you have a kid who isn't economically disadvantaged, they're actually going to get worse education in that school, or is it just the test scores are dragged down by kids who aren't having as much support at home?
Can you say that again?
So
Trying to wrap my mind around it.
Are the schools reflective of the quality of teaching or just reflective of the demographics going to that school? So if your kid isn't economically disadvantaged, in your case, you have the resources to help them develop or whatever, actually be disadvantaged going? Or
Yes. You could probably argue it either way, that the test scores are a result of the teaching or they are a result of the demographic population that goes to that school. I'd argue it's a little bit of both, but generally speaking, schools in areas that are economically disadvantaged have lower quality teachers and therefore lead to lower test scores.
it's interesting to compress it out and see if the differences remain.
Yeah.
It could also be parental involvement. Economically disadvantaged, probably working 2 or 3 jobs.
Yes, and it's really, we listened to a talk, I don't remember, Rachael Thomas, yes, about bias, especially in machine learning and in data science, about something like parental involvement is actually, will end up being code for race or end up being code for economically disadvantaged, or that they kind of overlap with it too. Yes.
Just 2 questions. One, you had said suppressed below 5% or above 95.
Yes.
Does that mean they're throwing it out entirely, or that they're just downweighting it?
It's my understanding that they're just hiding it from the public to be able to download.
And the other is, I mean, you had said that it's probably the quality of the teacher, but do you have the data, like the temporal data, to go back and compare a school to itself, knowing that the demographic has shifted or that the income level in that area has shifted?
Yes. I have it to a degree. I started out, so my initial capstone proposal that I sat and presented to a bunch of people was to be able to predict high school ACT scores based off of that cohort of kids' 3rd grade reading scores. And what I found in digging through data and trying to kind of piece that together was essentially that the structure of MNPS pathways, the amount of times that the testing has changed in MNPS over the last, even for like one cohort of 12 years, what we're testing now is not what we were testing 12 years ago. There's been so much variability and so much change that it's really difficult, or I found it to be really difficult to analyze, to be able to compare cohorts across time. To like attract real like longitudinal data for a kid. Yeah.
So Bridgewater Associates is a hedge fund,
Mm-hmm.
and they just recently did research on income inequality, and they were looking at schools too, just like this. What they found was that there is a very strong correlation between the amount of funding the school receives
Yes.
and the education that children receive at that school.
Mm-hmm.
And they also found something that was very interesting, was that the income that the parents make, that also coincides with the kind of education
Yes.
the student is going to get.
Yeah, I can definitely see that. I would love to have incorporated maybe in the future funding into this and comparing funding across schools, and then being able to like very similarly look at, particularly in Nashville, how different schools get different funding, and then what like the long-term effects of that are for kids and for families.
Yeah, and they later found out that actually that it turns out that when children don't get good education early on, they're not going to go to a good college, and then they won't have a good job later on too. So.
Yeah, a lot of it happens in those like first couple of years. If you can't read by, I was talking to someone who was saying if a kid can't read by the time they're in 5th grade, there's a very low chance that they will ever be on grade level in reading. Yes.
Just a follow-up question on the, you had mentioned some ACT scores. Is that, I know it's different now, is that a super score or is that individual scores?
You can't, like super score, do you mean for multiple test periods or for like broken out by subject?
Yeah, best of each subject. I think, isn't that how they report it now or something? And I guess that's what I was trying to understand. Was that for individual test results, or was that for that combined, almost that max on all categories?
That is for individual test results for like the individual subjects, so just for reading and then just for math. I believe for the ACT data, it is not super scored or sub-scored. They provide kind of like the raw, not maximizing it, especially because when you take the ACT at a school level with what the Tennessee Department of Education would report out, they only have one kind of seating, one test that you take of the ACT. It's that one time in your junior year that you take it that they report out, or they report it out by like that one sitting of it, not by the multiple times you've taken it throughout the year. Yes?
You mentioned in the beginning all the work that went into collecting the data and putting it into this app. I'm wondering if, because it looks to me like the data is dynamic, it's going to change year to year. And so I'm wondering if you're imagining a way to automate that data collection, or whether you think that you're going to have to just recollect the data every year and just append it.
That would be a really great thing to add. That would make a ton of sense to be able to like update it every year with the new test scores automatically, instead of having to go through and clean it and readjust it and rename the variables to what they were in the other data sets. That would be a great tool to add, yeah. Yes?
You touched on this a little bit, but you're calling the cohort by elementary, middle, high school, but is it individualized to a particular student?
It is not. So there's a lot of data privacy and data security that parents are very protective of. There is a really cool P30, P20 longitudinal data that Tennessee has a state tracking system for. It is not publicly available and requires lots of hoops to jump through to have access to that, just because of the level of security around individual student data. Whereas like this, you can't tie it back to a specific kid.
So is there under the assumption that the 300 people who went to elementary school ended up going to the high school?
Yes. Yes. And that's actually something I would love to investigate here. So this like drop that you see from elementary to middle to high school, and the rationale behind like why does an elementary school class that had 50% mastery go on to have 30% mastery when they get to high school? One argument, the content gets harder. What's easy in third grade wasn't so easy anymore when you got to the high school. What I think happens, especially in Nashville, that I couldn't quantify, that I want to quantify, is that these kids who are high performers at the elementary school level opt out of their zone schools and are opting out to magnet schools, to charter schools, to private schools, and are no longer represented in this data. Thank you.
Okay, well, thank you. And our final speaker for the night, certainly not the least, is Michael Holloway, who is actually now at NSS as an instructor. So Michael comes from a background in math, topology actually, right?
That's right, yeah.
Same other thing, so this is no stranger to conferences.
All right, thank you, Jason. So I did my capstone project on applying natural language processing to the arXiv mathematics preprint repository. So arxiv.org, that's a website where researchers in physics or mathematics or computer science or other fields will post preprints of their research papers, usually as PDFs. They'll sometimes post them in addition to publishing them in a normal journal, or sometimes instead of publishing them in a normal journal. But anybody who has done research in any of those fields has probably spent at least a little bit of time on the arXiv. The arXiv has a very nice API where you can get information on all of the papers that they have available. And for this project, I made use of that API to obtain metadata for almost 400,000 mathematics papers. Since my background is in mathematics, that was the area that I was most interested in. So my data set, broken down by year, looks like this. So it's much more, or papers starting from about the mid-2000s up through the 2010s are more heavily represented. But I did have a few papers that went back to the early 90s and even as far back as 1989. The papers within the mathematics field are split out into 32 different categories of varying popularities. The most popular by far is mathematical physics, followed by combinatorics and probability. Now these papers don't have to be in just one category. There's a lot of papers that are in two or even 3 or 4, up to 8 categories even. About 30% of the papers that I had belonged to 2 or more categories. So my objectives, what I wanted to do with this data set, I was interested in learning a little bit more about machine learning and natural language processing. So the first objective I wanted to do was to try to build a classifier that I could give a title and an abstract, and it would make a prediction as to what category that belonged to. However, I also wanted to have something sort of more practical that somebody could actually make use of. And so I also wanted to create a recommendation system to find papers similar to or related to a given paper. I'm going to go back briefly to this chart here. If you look, for the last 5 years, there have been greater than 30,000 mathematics papers posted per year on the archive, and so that's more than 80 papers per day. So it's very hard to sift through all of those papers and keep up to date on what everybody's doing. So I wanted a tool that people could use to help them find things related to a particular topic or a particular paper. Going hand in hand with this recommendation system, I wanted to allow searching by topic or by keyword, and so I worked on making an unsupervised keyword or key phrase extractor to assist in searching by topic. So I'm going to get a little bit into the classification model that I put together. I was working with text data, titles, and abstracts. Yes?
Sorry, I just have a quick question to try to understand more about this archive landscape.
Mm-hmm.
So when you count the number of view papers
Mm-hmm.
or posts, is it actually a new paper each time, or is it possible it's also like a revision, like somebody?
So quite often people will put up new versions of old papers, but in my data set it always has the most recent version of a particular paper. There are cases where somebody will sneak through and have the same paper posted twice, but they try to identify papers that are the same and put them all together. So again, I was working with text data, titles, and abstracts, and so the first thing I had to do is I had to do a little bit of pre-processing before I could feed this data into my model. These are mathematics papers. A lot of times they have equations or other mathematical notation. I tried to build something that would include that at first. It wasn't very successful, so I ended up just stripping out any kind of notation that I saw, along with stop words and other things. I had to vectorize that text data, and I ended up using a term frequency inverse document frequency, or TF-IDF vectorizer. And then the actual classifier that I used was a classifier chain model built on logistic regression models. So classifier chain, that's a type of model that's useful when you have multi-label data sets. So these papers, again, they might not necessarily land in one particular category. They might be 2 or 3 or 4 categories. And so this is sort of built to handle situations like that. And I'll get into that a little bit more on the next slide. Finally, as you saw a couple slides back, this is a very imbalanced data set. There are certain categories that are represented way more than other categories. And so I applied a random upsampling algorithm that I found that, again, was designed for this multi-label situation. I'm going to talk a little bit about how this classifier chain works. So I had 32 categories within mathematics that I was trying to classify papers into. So the way a classifier chain works is you train a binary classifier for each of those categories. So a binary classifier just says yes or no on that particular category. But you're not training these classifiers all independently or all separately. You train them in a sequential manner, one right after the other. And so, for example, in my case, I might have started with building a binary classifier to predict whether a paper is in differential geometry. So I would feed that the title and the abstract, and it would say either, yes, that looks like a differential geometry paper, or no, that doesn't look like a differential geometry paper. And then next, I would classify, I would build a classifier to predict whether a paper is a statistics paper. Now, this classifier would take the title and the abstract, but then it would also take the prediction from my first classifier, the differential geometry. So it would take those two pieces of information and then make a prediction about that category. And then I would maybe make a geometric topology classifier, again, a binary classifier. Now this one would feed on the title and abstract and then the two previous predictions. So as you go down the line, they're taking the previous predictions and then using that to predict the next category.
So that last step, is it seeing both outputs from the previous class?
It is, yeah. So really there should be an arrow from the first one all the way up there too. But you pass forward all previous predictions to the following classifiers. And the reason why this is useful for multi-label data sets is that it takes into account when you have a lot of overlap between categories or little overlap between categories. For example, in mathematics papers, there is quite a bit of overlap between differential geometry and geometric topology, as you might guess from the fact they both have geometry in their name. So if our first classifier predicts that a paper is in differential geometry, when we get to this third classifier, this one will know it, and so it might tend to put a higher probability on that paper also being in geometric topology. On the other hand, there's hardly any, or there might be no overlap between statistics and geometric topology. And so if the second one predicts statistics, the third one is probably not going to predict geometric topology.
Seems like sequencing would have an effect.
It will, yeah. So I trained a model using this classifier chain. I also trained a model with just a lot of 32 just independent binary classifiers. And what I saw on the left is the classifier chain, the sequential models. On the right is a one versus the rest, so that's just independent binary classifiers. And I saw like a 1% boost. It's not huge, but it's something. I did see a boost in the macro F1 score. So macro F1, that's the average over all 32 categories of the F1 scores. When I applied upsampling, I saw about a 2% boost on both of those. Is there a question? Yes?
How did you choose the classifier chain?
So I predicted the mathematical physics first because it was the most prevalent. I just did it in order of prevalence. In the original research paper where they proposed this method, they didn't really have a good order that you should do it in. They even suggested doing something like an ensemble where you train a bunch of them with random orders and then you average the results. So I just went with what seemed logical to me, most prevalent to least prevalent.
Now, these are labeled, right? So you actually know
Yes.
what the labels are.
I do, yes. Yeah. So again, this was sort of the less practical but more interesting from the, learning the.
Your model would probably be that. You might use the labels to give some feedback or something.
Sure. So I guess enough about the classifier for now. For my paper recommender, what I was using, I used those same TF-IDF vectors, and I generated recommendations by looking at cosine similarities to all the papers that I had in my data set. I also wanted to allow this searching by keywords or phrases to find relevant papers, and to accomplish that, I used an unsupervised keyword extractor. I found two papers where people had done something similar. One of them, they were using a method that they call key2vec. And then there's another one called YAKE, which that stands for yet another keyword extractor. But the ideas behind these are you want to do it in an unsupervised manner, so you don't have a list of approved tags ahead of time. You just want to generate those tags automatically from just a single document at a time. So you just take the title and abstract and analyze it and figure out, what might be a good tag, what might be a good label for this particular paper. And in math, there are tons and tons and tons of different topics, so I didn't want to try to compile a list of all possible topics, and plus those topics change over time too. So I thought taking an unsupervised approach might be best. So I took those 3 objectives, I rolled it all up into an app using Flask, and I'm going to demonstrate that app for you now. So this is the front page on the app that I put together. So the idea is someone can put in a title and an abstract, and then will analyze that for them. So I've pulled up, this is the actual archive here. So this is a paper that was posted on Monday. Perhaps you were browsing through the archive and you saw this paper. You really like exceptional W algebras. And I know, they're exceptional. So you can grab that title and that abstract and plop them into the app and hit analyze. And then what it does, it comes back, it reminds you what you put in. And then it gives you the categories that it thinks that paper belongs to. So in this case, this paper belonged to 3 different categories. It was representation theory, mathematical physics, and quantum algebra. And so my classifier got 2 out of those 3, which I guess is okay. I also wanted some explainability in what the model was doing. So like Harry, I used the Lime package. And so on these predictions, you can click on the prediction, and it takes a second, but it'll come up. On the left side, you can see the highest probability categories that it had, at least the abbreviations for them. So it was quantum algebra was the top, which was one of the correct ones. Representation theory was the second. And then mathematical physics, which was the 3rd category that the paper actually was the 3rd highest. It just wasn't confident enough to make that call. On the right side, here is the title and the abstract text. And so you can see which words most influence those predictions, or at least the Lime's, what Lime identifies as the most important words. And so in this case, fusion algebra's vertex came up as possibly being representative of quantum algebra. You can get a separate analysis for representation theory. So this one saw algebras, characters, et cetera, et cetera. Now below the predicted categories, I have this section where I have related papers. So this is the 5 most similar papers that are in the data set as far as TF-IDF cosine similarity. So for these papers, you can click on them and it'll take you right to the archive where you can download the PDF if you like. So again, we started with a paper about exceptional W algebras, and it found things about W algebras, etc. And then finally, at the bottom of the app, on the right side, these are the tags that my tagger suggested. It still needs some work as far as filtering out useless tags. It has things like ladder case, and there's some junk tags in there still. But it does have some potentially useful tags. W algebras was what it was talking about, exceptional affine W algebras, rational W algebras, etc. So if one of those tickles your fancy, W algebras, let's say, we can search for papers specifically tagged with W algebras, and it'll come up with the most similar papers tagged with W algebras. Now, perhaps you don't like W algebras. Maybe you're more interested in machine learning. If there's a particular tag you want to look for, you can also type in whatever tag you like machine learning, and you can say, find me papers, or find me the closest papers to the one I started with that are tagged with machine learning. And so it finds the papers. The similarity is very, very low, so there's not a lot of use of W algebras in machine learning apparently. But it tries. And so you can type in whatever tag you like, and it may or may not find any papers because there might not be any with that tag. But if there are, it'll give them to you, or it'll give you the most similar ones that there are. And that's it for my app. So. Yes.
So you mentioned trying to handle mathematical notation.
Mm-hmm.
What were some of the ways that you tried to encode that, or you tried to handle that? Let's say LaTeX.
So if you're doing LaTeX, you'll have slashes in front of things. So I tried to like strip out the slashes, or you might have underscores signifying different parts. So I tried initially to like parse out or split it up into different pieces. You might see int a lot, and that would be integrals or sums or things, but it was just a lot of work. And so I just was not successful at doing that. I tried some methods. I tried fast text, Facebook's fast text vectors, which is do a character level representation of words. And I thought, well, maybe I could build up a representation of this mathematical equation by building up in pieces, and it might recognize the different pieces. But it just did not perform as well as the simpler just strip it all out. Yes?
So I guess you can use as your input papers that aren't in the archive, right?
Yes.
Whatever you want.
Yeah. I guess hypothetically, if you're working on your own, a paper on your own, and you wanted to see, have other people done something similar, or what have other people explored that are similar to what I'm doing, and pull them up. Yeah. Mm-hmm.
So about the papers are with like a lower percentage of classes.
Mm-hmm.
So you use upsampling, and did you check the performance, how well it's doing the model?
So in terms of so here, this was the macro F1, so this is the average overall categories of the F1 scores. So upsampling, perhaps not too surprisingly, it did improve the macro F1 scores because you had a more representation of those minority classes. I looked at some other metrics. Let's see if this will pull up. So I was looking at Hamming loss. So F1 scores we want higher, Hamming loss we want lower. I tried not just logistic regression, I tried some other techniques as well, but pretty much all of them, when I upsampled, the Hamming loss actually went up a little bit. It's not clear if Hamming loss is the best metric to use. It's sort of an unusual situation, a lot of different classes and multiple classes per paper.
Have you used other techniques? Usually like ensemble techniques are working better with imbalance data.
Mm-hmm. Yeah, I hadn't explored or hadn't gone down that road as much as I would like.
So ensemble techniques that with cross validation usually works better with this kind of data.
Yeah, that could be something to explore more.
Yeah, we can talk about that.
Definitely, yeah.
Did you integrate any sort of weighting based on number of reads or downloads of the paper?
I didn't have access to that information. I really wanted to try to figure out what are people actually interested in, or what are people downloading. I guess that could have gone into the recommendation thing too, is here's popular papers that are similar, but at least, I think the archive just has a policy that they don't publish that information, how many downloads or how many views something has. So I'd have to go through a different source if I was going to do that. Yes?
So you said for this analysis, you just focused on like the most up-to-date version of each paper, but have you thought about comparing different versions of the same paper to see like how the keywords change, or maybe how the focus changes? Do you think that would be interesting?
I think that could be interesting, yes. Yeah. Another thing I would like to do, maybe not paper specific, but maybe more overall, is explore how topics changed over time as well. So maybe that would be the next step, is to see what are hot topics, or what has gone out of fashion now. Yeah.
Sorry if I missed it, but are the classification performance metrics, are they out of sample or in sample?
So these are, so I split off a training and a test set, and so this is performance on that test set. Yes?
What was the package that you used for the upsampling, the random upsampling?
I implemented it myself.
Okay. And I say with the chain classifier?
Mm-hmm. Yeah, so there actually is a library for that. It's like an add-on to scikit-learn. When I tried to use it, it kept giving me memory errors no matter what I tried, so I thought, oh, I'll just do it myself.
There's an interesting hashing algorithm for recommendation systems called locale sensitive hashing. Might be interesting to see how that works.
Yeah, I know there's a lot of sort of more.
That's the nice thing, it's super simple.
Yeah, I mean, I was sort of using like the simplest thing I could think of, and I know there's a lot more sophisticated or probably better thought out recommendation systems than what I had.
It's just surprising to me. It's like magic.
Cool, I'll have to look into that.
Well, does anyone else have any questions? Or we'll have a little bit of time here afterwards, and you can meet with any of the speakers if they're going to hang around. And with that, let's thank Michael, and I guess